Hello and welcome. My name is James Green of Ubersolar, and the topic of this webinar, stroke Zoom, stroke recording, is how do Ubersolar heaters work and why are they better? And by the end, I hope that you'll have a fairly good understanding of how our systems are different and how they work. So starting off, I'm going to show you a example of a system on a roof. It's slightly unusual because it's not normally how we'd look at something. But we have a 36 tube system sitting on a roof. And the reason I've chosen this photograph is because the tank is visible. It's a Class B tank. And the water is basically circulated from the tank up, if you're following my mouse, through the solar manifold and back down again into the geyser. And that goes on over the course of the day, powered by the PV panel. Now, this schematic shows it a little bit clearer. We have a 150 or 200 liter geyser. We have a pump. The water comes from there through the pump and is pumped up and through the heat exchanger in the solar manifold, which I'll explain more in a second, powered by a PV panel. And it then goes through a heat trap and back down into the geyser, and that goes round and round during the day. So here's another example. This is actually a 48 tube system with a 300 liter system rather than 150 or 200. The tanks joined together in series, exactly the same principle. The water is taken from the tank through the solar collectors and back again into the other tank, and they're joined together in series. So how does it work? The solar manifolds have a heat exchanger inside them. And in here, you will see that there is a corrugated stainless steel corkscrew, which is acting as the heat exchanger. And as we pull back and look at the manifold from slightly farther away, you'll see that there is another piece of corrugated at the back, which looks rather like a coat hanger, and I'll be explaining that a little bit more later on. But basically, that is the venting system, which is unique in this type of solar water heating system. So then we look and we go back, and that's what we just looked at is the solar manifold and the heat exchanger. And we now look at the evacuated tubes which are going into it. And the evacuated tube is around 1800 millimeters long, about 58 millimeters in diameter. It's two pieces of glass with a vacuum between them which improves the heat loss. And they are filled with water in our case, and they are inserted into the manifold. So here we are with the manifold. Here are some examples of the tubes being shown. There are the holes which they are going into. And if you look at it again here, you can see it with a rubber silicone seal, which actually seals that and holds the tube in place. So what is the performance of the tube? And that's what we're really looking at. In our case, each tube will have an output of around 0.27 to 0.35 of a kilowatt hour per day. And for example, with 30 tubes, that will be about 10.2 kilowatts. And the amount of electricity that actually is needed to heat 200 liters from cold at 16 Celsius to hot at 60 is 10.2 kilowatts. So it's the same as 30 tubes on the average South African day. And what we do is we match the tank sizes to the number of tubes for a theoretical 100% electricity replacement in all sizes. So we have an 18 tube system, which is either put on 100 or 150 liters for 1 to 2 people. We have a 24 tube, which gives about 7.5 kilowatts, which is ideal for 150 liters. Likewise, 30 tubes for 2 to 4 people, 36 tubes, 42 tubes, 48, and then we start getting bigger and bigger to 60, 96 tubes, etc. So what we've just gone and shown you there is that essentially we're a plug-and-play solution. The solar collector can be any size, and it can be on a pitched roof, flat roof, tiled, metal, slate. The tanks can be anywhere. They can be in the roofs, they can be on walls, they can be on the ground, they can be on flat roofs. We can do both retrofits, which are using your existing geyser, as well as complete systems where we provide another tank, and the electrical backup, which is necessary for guaranteeing hot water, or an alternative energy source is always going to be there. Now, one of the biggest problems, and it's something nobody ever really talks about with solar water heatings, is overheating. And overheating happens when one is in stagnation and no water is being used. We've overcome it by venting the manifolds and the tubes, and the maximum temperature that can be reached is just below 94 degrees Celsius in Johannesburg, slightly hotter in the Cape. And unlike other types of solar water heating systems, high pressure ones, we cannot overheat. So we explained to you that there was water in the tubes, which you can see on my mouse, and in the manifolds. And this thing, which looks like a coat hanger, is venting. So the maximum temperature in the water in this manifold, in all of them, can be 94 degrees. And at this end, you can just see the piece of pipe coming in and going out the other end. So the heat exchanger is in each one of those. So the heat exchanger and the water, which is inside the heat exchanger, which is high pressure, is being heated by the low pressure water, but the low pressure water can't get hotter than 94. Now, what does that mean? It's a really important advantage. We can use any number of tubes without overheating. We can put in more tubes, which means that we can achieve effectively a faster acceleration in temperature, whilst the top temperature or the top speed will remain the same. But what it really works is in somewhere like Cape Town, where you have fantastic summers but not very good winters, and you need an overpowered system in the winter and an underpowered system in the summer. And it's very difficult to achieve that if you don't have the approach of actually limiting the maximum temperature by science, in this case, the air and physics. We cannot get hotter than 94 degrees, which is a huge advantage. And we can, if you look at the whole thing, what you have is an evacuated tube has a couple of different heat transfer mediums. You can either have water, or you can have what's called a heat pipe riser, and we discussed that in another video. But when water is used, rather than the heat pipe riser, the cost of the tube, which is exactly the same tube in both cases, is about 60% cheaper. And the tube has very nearly the same output, whether it's a heat pipe riser or water. So therefore, we can actually put in more tubes, which means more power for less investment. So simplicity is the key to our systems. No other solar water heating system worldwide can match our performance for the investment cost. We can get more hot water from solar per rand invested. We can get more kilowatt hour savings. We get better outputs than gas or heat pumps. We achieve faster paybacks, higher returns on investment, greater safety, reliability, and longevity, and more flexibility. So the next steps are for you to get a quote and call us, a little chat on WhatsApp, visit the website, email us, be informed, and watch more educational videos. But I hope, having got to this stage, you have an understanding why we believe we're better. And it's actually because we went backwards in technology. We've made it simpler. We've made it cheaper, using the same components basically as everybody else, but just with higher performance. And with that, I'd like to say thank you. We look forward to talking to you in another video, and keep well in the meanwhile.